All right, so we're going to go over Module 7, Homework 2, which is adding and subtracting rational expressions. Remember, rational expressions are just fractions. And this section, this homework, is good because they are all common denominators. They're all common denominators. So in this section, we're going to find an LCD. What does LCD mean? A least common denominator. A least common denominator. We're going to add and subtract rational expressions with a common denominator, and we're going to simplify completely. So going back just like we did last section, we are going to review old school adding fractions. So we're adding 3/5 plus 1/5 for 1. Are these like terms? Yes, 3/5 and 1/5 are like terms. So 3 things plus 1 thing will give us how many fifths total? 4/5. Is there anything that 4 and 5 have in common to be simplified? No, so 4/5 is our final answer. Same thing for the next one. 7/9 minus 4/9. Are these like terms? Yes, they are both ninths. So if I have 7/9 minus 4/9, how many ninths are left over? 3/9. Simplify, good. So what do 3 and 9 have in common? 3, so we can factor or divide out of 3 from the top and the bottom. So our final answer is going to be 1/3. So notice that the final answer has to always be simplified. So that's it for this section. This section's good because they all have common denominators. They are all like terms. Bless you. So because I know what's coming up, and because on the test it's not going to say, okay, this is Module 7 Homework 2, and this is Module 7 Homework 3, it's just going to give it to you. I'm going to keep on asking you, are these like terms, even though for this section they all are going to be. So next example, add 1 over x minus 1 plus x over x minus 1. Are these like terms? They have the same denominator? Yes, that means we can just add across. So we have 1 of these things plus x of these things. So it'll give us 1 plus x over x minus 1. We need to simplify it. Okay, so let's try to put them in order. So the first one is x plus 1. The bottom one is x minus 1. If we were to take out a negative 1, would they cancel out?
No.
No, if we tried it, let's just say we took out a negative 1 from the top. It'll give us negative x minus 1. So it's not the same thing, so it cannot be simplified. So that's our final answer. Yes, sir? Yes. Good question. Yeah, either one of these is okay. Are okay. Thank you. What else? Other questions for me?
I like how the section's like thinking that we're dumb, but then it's going to give us a big surprise.
It's just getting you used to it. It's just getting you used to it. All right, so let's try another one. So subtracting y plus 3 over y minus 7 minus y minus 1 over y minus 7. Are these like terms? They have common denominators? Yes, so they're both going to be over y minus 7. Up top, we have y plus 3 minus y minus 1. Just like before, we're going to put our separate factors into parentheses to separate them. So parentheses usually mean distribute, so that way I can distribute everything. Is there anything outside of this first set of parentheses to distribute? A positive 1. Whenever we distribute positive 1, it's still going to stay. Y plus 3. What is outside the second set of parentheses to distribute? The negative. So distributing that negative, what's left over?
Negative y plus 1.
negative y plus 1, still over y minus 7. We're just trying to simplify the top. So now we combine like terms. Good. So y minus y is 0. They cancel each other out. We're left over with 3 plus 1, which is 4, over y minus 7. There are no factors in common, so it cannot be simplified. So that's our final answer. How could I help you? What questions do you have for me? Next page. Next page. So, perform the indicated operation. Simplify if possible. It gives us z squared over z plus 2 minus 4 over z plus 2. Are these like terms? Do they have the same denominator?
Yes.
Yes, so we can write them all over z plus 2. Of course, they give us z's and 2's in the same problem. That's why I write the ugly z. So up top we have z squared minus 4. Difference of 2 squares, we can factor the top. Z plus 2 and z minus 2. Notice z squared is z times z. 4 is 2 times 2. One's positive, one's negative. The bottom is z plus 2, so it's already factored for us. So what factors can cancel? Z plus 2. On top, we're left over with z minus 2. On the bottom, we're left over with 1. Z minus 2 divided by 1, just z minus 2. Final answer.
So if we know that it's going to be z minus 2 over the 1, is it okay that we take it straight forward and just do the z minus 2?
Yes, ma'am, that's fine. Yeah, if you don't want to write this step, that's totally okay, and just go straight z minus 2, nothing's on the bottom, done. That's okay. Thank you for asking. Other questions? If not, last one for this section. Perform the indicated operation and simplify. Yes, sir.
So you know how to cancel out the z plus 2 on this one?
Mhm.
How come we didn't do that on the beginning of the y?
So the question is, why didn't it cancel out
Yeah, like why did you do on the bottom?
this one?
Yeah.
Cancel out with what?
You don't use the one on the top.
Oh, sorry, I'm pointing to the wrong one. So y minus y goes to 0, so they cancel out. But we wouldn't be able to cancel it because we have to have the same factors. So what you're saying, for example, is why wouldn't these two x's cancel out? Is that what you're asking?
Yeah.
Like, why wouldn't those two x's cancel out? Or no? Sure. Is that what you're asking or no? Okay, they won't cancel because they're not this. They have to be exactly the same factors. So over here, they are exactly the same. They are both z plus 2, so that's why they can cancel. Yes, sir.
Go back to this question. What if that was, what if it was y minus 7 minus y plus 1? Would we be able to cancel that out? See where you're crossing out the y's?
Uh-huh. You can simplify the top first, simplify the bottom first. Once everything's simplified, then you can go ahead and start factoring. I'm sorry, start canceling. Does that answer your question? So make sure the tops, like we completely simplified this top first. We combine like terms. We completely simplified the bottom. There's nothing to combine. So now we have to see, okay, can I go any further, which we can't. So that's how we know we're done. What else? Other questions for me? Let's try another example. So we have to perform the indicated operation, simplify if possible. 5x minus 10 over x squared plus x minus 6 plus 7 minus 6x all over x squared plus x minus 6. Are these like terms? They have the same denominator. Yes, we can write them over the same fraction. All over x squared plus x minus 6. On the top we have 5x minus 10 plus we have 7 minus 6x. Notice they are their own fractions, so that's why I put them as their own factors in parentheses. So what is out front of this first set of parentheses to distribute? Nothing is a positive 1, so it's going to stay 5x minus 10. What is outside of the second set of parentheses to distribute? Same thing, positive 1, so it's going to stay plus 7 minus 6x all over x squared plus x minus 6. So like we talked about, we have to simplify the top first. So 5x minus 6x, combining like terms. 5x minus 6x, negative 1x. And then we have negative 10 plus 7, negative 3. All over x squared plus x minus 6.
Would you want to take that negative x minus 3, negative 1 out now or later?
Yeah, we can do it now. I know they both have a negative in common, so let's take out that GCF of negative 1. So taking out that GCF of negative 1, what's left over? X plus 3. So notice, once we get to this step, now it's just like the previous problems we've done in homework 1. We're just simplifying. So we now need to factor x squared plus x minus 6. GCF? No GCF. Our A value is 1. B is also 1. And C is negative 6. So we are looking for two numbers that multiply together to give us A times C, which is negative 6. And the same two numbers to be added together to give us B, which is positive 1. 3 and negative 2. So 3 times negative 2 is negative 6. 3 plus negative 2 is positive 1. Thankfully, because A is 1, we can go straight to our factors of x plus 3 times x minus 2. So up top we have negative times x plus 3 all over x plus 3 times x minus 2. What factors can cancel? X plus 3. So up top we are left over with negative 1 all over x minus 2. There's no other factors in common, so that will be our final answer. That is all of Module 7, Homework 2.
Oh.